go in this lecture, we'll answer two questions. In the first question, we'll find out the length of this line segment AQ is equals to x. We have to find out the value of x. And in the second question, we'll find out the area of this quarter circle A or B. So we start with the first question. In the drawing, we have semicircle APCB. Note that this is called CB. This equals to 5 units in its length. This is line segment QC. This equals to 6 units in its length. We also know that arc CB equals to arc AP in its length. And this is again PQC. That is the right angle. Again, our task is to find out the length of this line segment AQ is equals to x. We have to find out the value of x. So this is peripheral ACB. Peripheral ACB subtend on AB, the diameter of this semicircle, and according to rule 7, any peripheral that subtend on the diameter of the circle or semicircle must be equal to 90 degrees in its size. And therefore, peripheral ACB equals to 90 degrees in its size according to rule 7. So I paint quickly on rule 7. So according to rule 7, if a peripheral angle subtends on the diameter of the circle or semicircle, then it is equal to 90 degrees in its size. So in the drawing, we have a circle, and we know, and this is peripheral ACB that subtend on chord AB. This is the diameter of this circle. And according to this rule 7, peripheral ACB must be equal to 90 degrees in size because of the fact that it's subtend on the diameter of the circle. So we can implement rule 7 in our drawing. We'll put in our drawing. This is peripheral ACB that subtend on AB, the diameter of this semicircle, and therefore according to rule 7, peripheral ACB must be equal to 90 degrees in its size. It is given us the question that arc AP equals to arc BC in its length. So we know arc AP equals to arc CB in its length. Here the rounded sign above AP and CB is the sign for arc. It means that arc AP equals to arc CB in its length. And so here we can implement rule 56. We can click on rule 56. According to rule 56, if two arcs are equal in length, then their corresponding chords are also equal in their lengths. The drawing in a second. This is arc AB equals to this arc CD in its length. Okay, again, those two arcs are equal to each other in their lengths, and therefore, according to this rule 56, their corresponding chords must be also equal to each other in their lengths. The corresponding chord of this arc AB is chord AB, and the corresponding chord of this arc CD is chord CD. So chord AB equals to arc CD in its length because of the fact that those two arcs are equal to each other, and therefore their corresponding chords, that is to say AB equals to CD, must be also equal to each other. So we can implement rule 56 in our drawing. Then put in our drawing. First of all, we join points P and A together by a straight line. So, in our drawing, arc AP equals to arc CB in its length, and therefore according to rule 56, the corresponding chords of those two arcs must be also equal to each other in their lengths. The corresponding chord of this arc is chord AP, and the corresponding chord of this arc is code CB. And according to Rule 56, the corresponding codes are equal to each other. That is to say, code PA equals to code CB in its left according to Rule 56. On the fact that RKP equals to RCB, we will derive that their corresponding codes must be also equal to each other in their length. That is to say, RKP code AP equals to code CB in its length, according to Rule 56. But it is given us the question that code CB equals to 5. So can I tell that code CB equals to 5? And for this equation, code AP equals to code CB equals to 5. We derive that code AP must be also equal to 5 units in its length. Code AP equals to 5 units in its length. This is called AP, equals to 5 units in its length, according to Rule 56. In the next step, we will join points P and C together by a straight line. By joining points P and C, we can get there triangle PCQ. Triangle PCA. This is triangle PCA that subset on code AP that was for 5 units in its length. Likewise, this is triangle BAC. This is triangle BAC that subset on this code CB that is also equals to 5 units in its length. And because of the fact that those two triangles subset on equal codes, they must be equal to each other and their sizes. That is to say, triangle PAC must be equal to triangle PCA in its size. So those two triangles must be equal to each other and their sizes because of the fact that they are both subset on equal codes, according to Rule 57. So repeat quickly Rule 57. So according to Rule 57, if two peripheral angles subtend on equal codes, then they are equal to each other in their sizes. So in the drawing, in a second, this is peripheral EDF that subtend on code EF. Likewise, this is peripheral ACB that subtend on code AB in its length. And this is peripheral ACB that subtend on this code AB. And we know that code EF equals to code AB in its length, and because of the fact that those two peripherals subset on equal codes, they must be equal to each other and their sizes. That is to say, this is peripheral angle EDF that equals to peripheral BCA in its size, or alpha equals to beta. So because of the fact that those two peripheral angles subset on equal codes, they must be equal to each other, and they must be equal to each other in their length, in their sizes. That is to say, alpha equals to beta. So already mentioned before, we can implement Rule 57 in our drawing. Like in our drawing, those two peripherals subset on equal codes. The length of the code is 5. Therefore, they must be equal to each other in their sizes. That is to say, this is peripheral PCA. And it must be equal to this peripheral CAB. According to Rule 57. Repeat again. peripheral angle PCA must be equal to peripheral angle CAB in its size because of the fact that those two peripheral angles subtend on equal chords. So if we define the size of this peripheral angle CAB as alpha, then the size of this peripheral angle PCA must be also equal to alpha because they are equal to each other. Okay. If peripheral angle PCA equals to alpha, then peripheral angle CAB must be also equal to alpha because they are equal to each other. In the next step, we focus on this right triangle, triangle ACB. In this right triangle ACB, this angle equals to alpha, this angle equals to 90 degrees, and therefore this angle must be equal to 90 degrees minus alpha. Why? Because 90 degrees minus alpha plus alpha is 90 degrees, and 90 degrees plus 90 degrees, it is equal to 180 degrees, that is the sum of the angles in any triangle. Likewise, in this triangle APC, this angle, this triangle QPC, this angle equals to alpha, this angle equals to 90 degrees, and therefore this first angle must be equal to 90 degrees minus alpha according to the sum rule that states that the sum of the angles in any triangle is equal to 180 degrees. Okay, so in the next step, we prove that this is again right triangle PQC. So this again right triangle PQC is similar to this lower right triangle, triangle ACB. So why the green triangle PQC is similar to the right lower triangle, triangle ABC? First of all, those two angles are both equal to alpha and therefore they are equal to each other. In addition, those two angles are both equal to 90 degrees minus alpha and therefore they are equal to each other. And finally, both those two angles are equal to 90 degrees and therefore they are equal to each other. So we actually prove that all the angles in this right green triangle PQC are corresponding equal to all the angles of this right triangle, triangle ABC. And therefore those two right angles are similar to each other according to angle similarity rule. So write it down. So if you prove that this is again right triangle PQC, and it's similar, this is the sign of similar to this right lower triangle, triangle ABC. According to angle similarity rule. And again, I should remember that the green right triangle PQC is similar to the right lower triangle ABC according to angle similarity rule. And from the fact that those two right triangles are similar to each other, we will derive that the following relationship exists between their sides. We will derive that side PQ of this green right triangle PQC or side CB of this right lower triangle ABC is equal to side QC of this green right triangle PQC over side AC of this right lower triangle, triangle ABC. So if you know, PQ over CB equals to QC over AC. Repeat again from the fact that the right triangle PQC is similar to this right lower triangle, triangle ABC. We derive that the following relationship exists between their sides. we will graph that side PQ of the right triangle PQC over side CB of the right triangle ABC equals to side QC of the right triangle PQC over side AC of the right triangle ABC. PQ is the missing side, so leave it as it is. Over CB, CB is 5, according to what is given as the question. And it is equals to QC, QC is 6, according to what is given as the question. Over AC, AC in total equals to X plus 6. So in total, if you found out that PQ over 5 equals to 6 over X plus 6. Here we cross multiply this equation. And get that 6 times 5 is 30, so 30 equals to PQ. Actually we can multiply this equation by 5 and we get that PQ over 5 is PQ. And here 6 times 5 is 30, so in this side of the equation we have 30 over X plus 6. So in total we found out that the missing side PQ equals to 30 over X plus 6 units in its length. We multiply the equation by 5. So here, this is the missing side PQ, and it was to 40 over X plus 6 units in its length. So write it down. PQ equals to 30 over X plus 6 units in its length. In the next step, we implement the Pythagoras theorem on this, what we call that. AC is a straight line according to what is given as the question. So if we focus on the upper side of the straight line AC at point Q, here the sum of the areas must be equal to 180 degrees according to all three. All three states that the sum of the areas on one side of the straight line is equal to 180 degrees. So which angles we have at the upper side of the straight line AC at point Q, we have this angle that is right angle, plus this missing angle. In total the sum of those two angles must be equal to 180 degrees according to all three. Therefore this missing angle must be equal to 90 degrees in its size. According to all three, so already mentioned. Let's go. So here we have the right line APQ. So in the next step, we represent the Pythagoras theorem on this right line APQ. According to the Pythagoras theorem, in any right triangle, the square of the hypotenuse equals to the sum of the sides of the perpendiculars. So in this right line APQ, here by PT is the abbreviation for Pythagoras theorem. According to the Pythagoras theorem, this right line APQ, AP squared, that is the square of the hypotenuse, is equal to PQ squared plus QA squared. And again, according to the Pythagoras theorem, in this right line APQ, AP squared, this is the square of the hypotenuse, equals to PQ squared plus QA squared. the hypotenuse AP equals to 5 units in itself, and therefore AP squared is 5 squared, that is 25. And it is equal to PQ squared. PQ is 30 over x plus 6, and therefore PQ squared is 30 over x plus 6 squared. Plus AQ squared. AQ is x is the number that we're looking for in this question. So AQ is x, therefore AQ squared is x squared. So in total, we should know that 25 equals to 30 over x plus 6 squared plus x squared. So 25 equals to, we have 30, we open the brackets of this expression, 30 over x plus 6 squared equals to 30 squared, that is 900, over x plus 6 squared. And we have here plus x squared. So here we multiply x squared by x plus 6 squared, then we divide it by x plus 6 squared in order to come factor with this expression. So x squared, so it is plus x squared times x plus 6 squared, and then we divide it by x plus 6 squared, so we change nothing. So in total, we should find out that 25 equals to 900 plus x squared times x plus 6 squared over x plus 6 squared. So here we multiply this equation by x plus 6 squared. And we get that 25 times x plus 6 squared equals to 900 plus x squared times x plus 6 squared. So we have here 25 times x plus 6 squared. X plus 6 squared equals to x squared plus 6 squared, that is 36, plus 2 times x times 6, that is 12x. And it equals to 900 plus x squared times x plus 6 squared. So we open the brackets of this expression and we get that x, but before that we open, we find out what is the value of x plus 6 squared. So here we have x squared plus x plus 6 squared. X plus 6 squared equals to x squared plus 6 squared, that is 36, plus 2 times x times 6, that is 12x. So here we open the brackets on both sides of this equation, and finally we get that 25 times x squared is 25x squared, plus 25 times 36 is 900, and we have 25 plus 12x is 300x, and it's equals to 900. And we have here x squared times x squared plus 36 plus 12x. So we open the brackets of this expression and find that x squared times x squared is x to the power of 4, and x squared times 36 is 36x squared, and we have x squared times 12x equals to 12x cubed. Is 12x cubed. So here we have 900 on both sides of this equation, so 900 will get cancelled. After I cancel 900, in this side of the equation we left only with 25x squared plus 300x, and it equals to, here we have x to the power of 4 plus 12x cubed plus 36x squared. Here we subtract 25x squared from this equation, and you get that in the side of the equation we have to leave 300x, and it is equals to x to the power of 4 plus 12x cubed, and we have 36x squared minus 25x squared is 11x squared. So here we subtract 300x from this equation, and you get that x to the power of 4 plus 12x cubed and we have here plus 11x squared minus 300x equals to 0. Then again, if we found out that x to the power of 4 plus 12x cubed plus 11x squared minus 300x equals to 0. So here we take out x as a common factor from this long equation, from this long expression. After we took x as a common factor, inside the brackets we left from this expression with x cubed, and here from this expression we have to leave 12x squared. What is left from this expression after we took from it x as a common factor? What is left is actually 11x. What is left from this expression after we took from it x as a common factor? What is left is actually minus 300 equals to 0. So here we have two solutions for x to this equation. According to the first solution to this equation, x equals to 0. So here, if x equals to 0, 0 times anything is 0. So here in this side of the equation we have 0 equals to 0. So 0 equals to 0. The other possibility, the other solution for this expression, that this expression x cubed plus 12x plus 11x minus 300 equals to 0. And so if this expression equals to 0, then 0 times anything is 0, so we get that 0 equals to 0. So the second solution to this equation is x cubed plus 12x squared plus 11x minus 300 equals to 0. Actually, x can never be equal to 0. Why? Because of the fact that x is the length of this line segment AQ. So x is a length, and this length, it must be a positive number. It can never be equal to 0. Therefore, we consider the solution x can never be equal to 0. And we have to leave the other solution that is possible, that x cubed plus 12x squared plus 11x minus 300 equals to 0. So first of all, we check that if this equation is true for x equals to 3. So if x equals to 3, then we get that this expression in total will be equal to x cubed. X is 3, so x cubed is 3 cubed. That is 3 times 3 times 3, that is 27. Plus 12x squared. X is 3, so x squared is 3 squared, that is 9, and 9 times 12 is 108. Plus 11x. X is 3, so 11x is 11 times 3, that is 33. And minus 300 equals to 0. So x cubed is 27, plus 11x is 108, plus 2x squared is 108, and 11x is 33. Minus 300, it should be equal to 0. But we have here 27 plus 108 plus 33, in total it is 168, minus 300 is definitely not equal to 0. That is to say, if x equals to 3, this equation is not true, therefore x can never be equal to 3. So in the next step, we check if x equals to 4, solve this equation. Repeat again, we check that if x equals to 4, it solves this equation. So if x equals to 4, then we have here, if x equals to 4, solve this equation. X cubed plus 12x squared plus 11x minus 300 equals to 0. So if x equals to 4, then x cubed is 4 times 4 times 4, that is 64, plus 12x squared. X is 4, so x squared is 4 squared, that is 4 squared, that is 16, and 16 times 12 is 192. Plus 11x. X is 4, therefore 11x is 11 times 4, that is 44. Minus 300. So here we have 64 plus 44 is 108, and 108 plus 192 is 300. So 300 minus 300 equals to 0. So if x equals to 4, then this equation is true. Therefore, the first solution for x is that x equals to 4 units in its length. This is answer in Q, equals to 4 units in its length. And we can display this expression in another form. Here we have x cubed plus 12x squared plus 11x minus 300 equals to 0. And again, we have found out that this equation is true for x equals to 4, and therefore we can display this expression in another way. This expression in total is equals to 0. So this in this side of the equation we have this expression. We can display this expression in another form. This expression in total equals to x minus 4 times x squared plus 16x plus 75. Okay, again, this expression is identical to this expression, so this expression equals to 0, so this expression also equals to 0. So what we did here, actually, we presented this expression in another form. Those two expressions are identical, they are just written in two different forms. So, as we found out that if x equals to 4, this expression is true, this equation is true. So this equation has also two solutions. The first solution to this equation is x minus 4 equals to 0. If x minus 4 equals to 0, then 0 times anything is 0. So we get that 0 equals to 0. If x minus 4 equals to 0, it means that x equals to 4. So the first solution for x is that x equals to 4. We check, but if this expression equals to 0, then 0 times anything is 0. And get that 0 equals to 0. So the second solution to this equation is that this quadratic equation equals to 0. Which is 75. And again, the equation is x minus 4 times x squared plus 16x plus 75 equals to 0. So if this expression equals to 0, then 0 times anything is 0, so we get that 0 equals to 0. So if x squared plus 16x plus 75 equals to 0, then 0 times anything is 0. So now we have to check that if this quadratic equation is true. Again, we check that if the quadratic equation x squared plus 16x plus 75 equals to 0, if this quadratic equation has any solutions. That the determinant of this quadratic equation is equals to b squared minus 4 times a times c. B is 16, so b squared is 16 squared. And 16 squared equals to 256 minus 4 times a times c. This is the determinant of this quadratic equation. So it is minus 4 times a is 1, so minus 4 times 1 is minus 4 times 75. Minus 4 times 75 is minus 300. 256 minus 300 is a negative number, it is less than 0. So the determinant of this quadratic equation is less than 0. So if the determinant of a quadratic equation is a negative, there is no solution for the quadratic equation, and therefore this equation is not true in the sense that it doesn't have any solutions at all. There is no x, there is no real number that equals to x that can solve this equation, this quadratic equation, and therefore this is not a true possibility. Another way to prove that this equation is not true is that just to substitute 75 by 64 plus 11, so this quadratic equation in total will be equal to x squared plus 16x. 75 is 64 plus 11, so we substitute 75 by 64 plus 11, so it must be equal to 0. This expression x squared plus 16x plus 64 is equal to x minus 8 squared plus 11, it must be equal to 0. So here we subtract 11 from this equation, and finally we get that x minus 8 squared equals to minus 11. X minus 8 squared is definitely a positive number. X can never be equal to 8. One because in this right triangle APQ, AQ is x. The opponent's PA is 5. The opponent is the longest side in any right triangle, and therefore AQ must be equal to less than 5. AQ, the x is less than 5, so x is less than 5, and therefore x minus x squared is definitely a positive number. But 11 is a negative number. And a negative number can never be equal to a positive number. So this quadratic equation has no solutions, and therefore the possibility that x squared plus 16x plus 7 equals to 0 is an incorrect possibility, so we cancel this solution, and we left only one solution for x, that is x equals to 4 units in its length. So x equals to 4 units in its length. AQ equals to x equals to 4 units in its length. And again, the answer to this question is that this is 978 AQ, this equals to x, and x equals to 4 units in its length. So we finish to answer on the first question. In the next step, I present you the second question, and you solve the second question of this lecture. Our task in the second question is to find out the area of this quarter circle AOB. So in the drawing we have quarter circle AOB. This is a right angle, it is true in any quarter circle, angle AOB is a right angle. In addition, we know that this is 970 AQ, that equals to 4 units in its length, this is 970 PQ, this equals to 4 units in its length, and this is angle PQA, this is a right angle. Again, our task is to find out the area of this quarter circle AOB. So first of all, OA equals to OB, they are both the area of the quarter circle, and therefore they are equal to each other. So if we define the radius of this quarter circle as R, then OA is the radius of this quarter circle, this is equals to R units in its length according to our definition. Likewise, OB is also the radius of this quarter circle, is equals to R. So we know that in a triangle, in front of equal sides, there are equal angles. So in this right triangle AOB, in front of those two equal sides, we have those two angles that must be also equal to each other and their sizes, according to the rule that I mentioned. So if we define the size of this angle as x, and again, if we define the size of this angle as x, that is equals to, that is to say angle ABO equals to x units in its size according to our definition, then the size of this angle BAO must be also equal to x units, to x degrees in its size. Okay, and we also know that the sum of the angles in a triangle is equal to 180 degrees. So which angles we have in the right triangle BOA? We have x plus x, this is 2x, plus 90 degrees, in total must be equal to 180 degrees. So I have it now. In the right triangle ABO, the sum of the angles must be equal to 180 degrees. That is to say 2x plus 90 degrees, in total must be equal to 180 degrees. So in the right triangle ABO, the sum of the angles must be equal to 180 degrees. That is to say 2x plus 90 degrees, in total must be equal to 180 degrees. Here we will subtract 90 degrees from this equation. And we get that 2x equals to 180 degrees minus 90 degrees. This is 90 degrees. So 2x equals to 90 degrees. Here we will divide this equation by 2. And we get that the missing angle x equals to 90 degrees over 2, that is 45 degrees in its size. So actually, this is the missing angle x is equals to 45 degrees in its size. Likewise, this is also angle BAO equals to x is equals to 45 degrees in its size. So in the next step, we will do a construction, that is to say from point O, that is the center of this quarter circle, we will do perpendicular on AB. Again, from point O, we will do perpendicular on AB. So actually, this angle equals to 90 degrees in its size, and this angle also equals to 90 degrees in its size according to our construction. We will define the touching point of the perpendicular from point O and AB. This point is point M. By doing this construction, we can do the right triangle AMO. This is the right triangle AMO. This right triangle AMO, the sum of the angles must be equal to 180 degrees. So which angles we have in the right triangle AMO? This is the size of this angle is 45 degrees plus 90 degrees. In total, it is 135 degrees. So 135 degrees plus the size of this third missing angle in total must be equal to 180 degrees, and therefore this third missing angle must be equal to 45 degrees in size. 135 degrees plus 45 degrees is 180 degrees. So this missing angle must be equal to 45 degrees in size. We will continue to focus on this right small triangle AMO. we have the rule that says that in front of equal angles in the triangle they are equal sides. So in front of those two equal angles in this right triangle AMO, we have those two sides that must be also equal to each other in the length. That is to say, side AMA must be equal to side MO. In the right triangle AMO, according to the rule that I mentioned, side AM must be equal to side OM. AM equals to OM. But AM in total equals to 4 plus OM. So we define the length of right side OM as X. So in total, the length of side AM is equal to 4 plus X, or X plus 4. So you can write here that AM equals to X plus 4. And for this equation, X plus 4 equals to AM equals to OM, we will derive that OM must be also equal to X plus 4 units in its length. And again, we should find out that the missing side OM, this is the missing side OM, is equal to X plus 4 units in its length. So AM equals to OM, they are both equal to X plus 4 units in their lengths. Therefore, this is the right triangle AMO that is also an associated triangle. So in the next step, we will implement the quadratic theorem on this right and associated triangle, triangle AMO. Here by P it is information from quadratic theorem. So in this right triangle AMO, according to the quadratic theorem, AO squared, that is the square of the hypotenuse, equals to AM squared plus MO squared. Repeat again, in this right triangle AMO, according to the quadratic theorem, AO squared, that is the square of the hypotenuse, equals to AM squared plus OM squared. The hypotenuse AO is the missing side, so we leave it as it is, so it is AO squared AO squared equals to AM squared. AM is X plus 4, therefore AM squared is X plus 4 squared, plus OM squared. OM is also X plus 4, therefore OM squared is X plus 4 squared. So in total, we should find out that AO squared equals to X plus 4 squared plus X plus 4 squared. So AO squared equals to X plus 4 squared plus X plus 4 squared equals to 2 times X plus 4 squared. So here we take a root out of this equation. We take out the root of this equation, and we get that the missing hypotenuse AO. AO is the hypotenuse of this right triangle AO, but AO is also the radius of the quarter circle, equals to R. So the missing radius of the quarter circle AO equals to the square root of 2, and we have, and the square root of X plus 4 squared is X plus 4. The root cancels the square, and we left only with X plus 4. So in total, we found out that the radius AO of the quarter circle equals to the square root of 2 times X plus 4 units in its length. This is the radius AO of the quarter circle. that according to our definition is equals to R, and it is equals to the square root of 2 times x plus 4 units in its length. In the next step, we will do another construction. That is to say, we will draw perpendicular on line 7 PQ at point P. Again, we will draw a perpendicular on this line 7 PQ at point P. So actually, this angle equals to 90 degrees inside according to the construction. And we will extend line segment OM by side line until it touches the perpendicular from point P. And we define the touching point of the extended perpendicular from point P in the extended OM. This point is point N. OM is a straight line, and it's a perpendicular, it is absolutely a straight line, and when you extend it straight line by straight line, the result ON is also a straight line. So ON is a straight line. So if you focus on the lower side of the straight line OM at point M, here the sum of the angles must be equal to 180 degrees according to rule 3. Rule 3 says that the sum of the angles from one side of a straight line is equal to 180 degrees. So which angles we have at the lower side of the straight line OM at point M? We have this angle that is the right angle plus this missing angle. In total, the sum of those two angles must be equal to 180 degrees according to rule 3. Therefore, this missing angle must be equal to 90 degrees in its size. According to what is given us the question, AB is a straight line. So if we focus on the upper side of the straight line AB at point Q, here the sum of the angles must be equal to 180 degrees according to all three. So which angles we have at the upper side of the straight line AB at point Q? We have this angle that is the right angle plus this missing angle. In total, the sum of those angles must be equal to 180 degrees according to all three. Therefore, this missing angle must be equal to 90 degrees in its size. By doing the construction, we can do quadrilateral NMQP. Inside this quadrilateral NMQP, we have 1, 2, 3 angles. The sum of 3 angles is 270 degrees. So 270 degrees plus the size of this fourth missing angle PMN, PNM. In total, the sum of those 4 angles must be equal to 360 degrees according to the rule that says that the sum of the angles in any quadrilateral is equal to 360 degrees. So I write it down. If quadrilateral PNMQ the sum of the angles must be equal to 360 degrees. That is to say 270 degrees plus the size of this fourth missing angle, the angle P and M. In total, they must be equal to 360 degrees according to the rule that says that the sum of the angles in any quadrilateral is equal to 360 degrees. So here we subtract 270 degrees from this equation. And so you get that the missing angle P and M, the missing fourth angle P and M is equal to 360 degrees minus 270 degrees is 90 degrees. Okay, this is the missing angle P and M is equal to 90 degrees in size. So in quadrilateral PNMQ, we have 4 angles, and therefore we can relate to quadrilateral PNMQ as a rectangle. because it has 4 right angles. But we also know that the opposite sides of a rectangle are equal to each other. So in this rectangle PNMQ, side QM must be equal to the opposite side PN, but QM is x, and therefore the opposite side PN must be also equal to x units in its length. Likewise, according to the symbol in the same rectangle PNMQ, side PQ must be equal to the opposite side NM, but PQ is 3 according to what is given in the question. Therefore, NM must be also equal to 3 units in its length. In the next step, we join points O and P together by straight lines. Point O is the center of the quarter circle, point P is the point of the quarter circle itself, therefore OP is the radius of this quarter circle, R, and we already found out that the radius equals to square root of 2 times x plus 4 units in its length. So OP, radius OP equals to the square root of 2 times x plus 4 units in its length. In the next step, we will implement the Pythagoras theorem on this right triangle O and P. And again, we will implement the Pythagoras theorem on this right green triangle O and P. Here by P it is evaluation for Pythagoras theorem. So in this triangle O and P, according to the Pythagoras theorem, OP squared, that is the square of the hypotenuse, equals to Pn squared plus NO squared. And again, in the right hand triangle PNO, according to the Pythagoras theorem, OP squared, that is the square of the hypotenuse, equals to Pn squared plus NO squared. The hypotenuse OP, that is also the radius of the quarter circle, equals to the square root of 2 times x plus 4. And therefore the square of the hypotenuse OP squared must be equal to the square root of 2 times x plus 4 squared. And again, the square of the hypotenuse OP squared is equal to the square root of 2 times x plus 4 squared, and it is equal to Pn squared. Pn is x, and therefore Pn squared is x squared plus NO squared. NO in total equals to 3 plus x plus 4, that is x plus 7. So ON equals to x plus 7, and therefore ON squared equals to x plus 7 squared. So in total, we should find out that square root of 2 times x plus 4 squared equals to x squared plus x plus 7 squared. We will open the brackets on both sides of this equation. And we get that square root of 2 squared is 2 times x plus 4 squared equals to x squared plus x plus 7 squared. X plus 7 squared equals to x squared plus 7 squared, that is 49, plus 2 times x times 7, that is plus 14x. So it is 2 times x plus 4 squared. X plus 4 squared equals to x squared plus 4 squared, that is 16, plus 2 times x times 4, that is 8x. and is equals to x squared plus x raised to 2x squared plus 49 plus 14x. So here we open the brackets on this side of this equation. We get that 2 times x squared. 2 times 16 is 32, so it is plus 32. And 2 times 8x is 16x. And it equals to 2x squared plus 49 plus 14x. So here we have 2x squared on both sides of this equation, so 2x squared gets cancelled. After you cancel 2x squared, and this side of the equation we left only with 32 plus 16x, and the other side of the equation we left only with 49 plus 14x. Here we will subtract 14x from this equation. We get that 16x, of course. We have here 32, and 16x plus 14x is 2x, is equal to 49. 14x plus 14x is 0. So in total we should find out that 32 equals to 49, 32 plus 2x equals to 49. So here we subtract 32 from this equation. So you get that 2x equals to 49 plus 32 is 17. So 2x equals to 17. Here we will divide this equation by 2 and finally get that x equals to 17 halves. So this is line 7 QM is equals to x and x equals to 17 halves, and this is line 7 PN is equals to x and x equals to 17 halves units in its name. Writing down, we should hold on that x equals to 17 halves units in its name. Our task is to find out the area of this quarter circle AOB. So what is the area of quarter circle AOB? A quarter circle is 1/4 of a circle. The area of the circle equals to pi times the radius of the circle squared, and therefore the area of the quarter circle must be equal to pi times the radius of the circle squared over 4. And therefore the area of this quarter circle AOB the area of this quarter circle AOB must be equal to pi times the radius of the circle squared over 4. Which is pi times the radius of the circle squared over 4. The radius of the circle is equal to AO, that is actually equals to square root of 2 times x plus 4. So it is pi over 4 times the radius of the circle. The radius of the circle is also equals to the radius of the quarter circle, of course. The radius of this quarter circle equals to the square root of 2 times x plus 4. And the radius square equals to square root of 2 times x plus 4 squared. So in total, the area of this quarter circle AOB equals to pi over 4 times square root of 2 times x plus 4 squared. So it is actually equals to pi over 4. We open the brackets of this expression, we'll open the brackets of this expression, and we get that square root of 2 squared is 2 times x plus 4 squared. So in total, the area of this quarter circle will be equals to 2 over 4 is 1 half, so it is pi over 2. And we have x plus 4 squared. X is 17 halves, so we sum x by 17 halves plus 4 squared. So the area of this quarter circle will be equals to pi over 2 times 17 over 2. Here we multiply 4 by 2 and then we divide it by 2 in order to come out of this number. So 4 times 2 is 8. Then we divide it by 2, so we change nothing. So in total, the area of this quarter circle will be equals to pi over 2. Inside the brackets we have 17 plus 8 is 25 over 2 squared. So in total, the area of quarter circle will be is equal to pi over 2. We have here 25 over 2 squared is 25 squared, it is 625. Over 2 squared, it is 4. So in total, in the numerator of this expression, we have 625 pi over 4 times 2. 4 times 2 is 8. So in total, the area that we are looking for this equation, the area of this quarter circle will be equals to either 625 pi over 8 squared units in size, or terms of numbers, the area of this quarter circle is equal to 245.437 square units in size. Okay, again, we should know that the area of this quarter circle is equal to either 625 pi over 8 square units in size, or terms of numbers, the area of this quarter circle is equal to 245.437 square units in size. So we finished the answer on the second question. So in the next step, I summarize the lecture. That is to say, I repeat on the solution of the first question, then we repeat on the solution of this second question. Our test in the first question is to find out the length of this line segment AQ. This equals to x. We have to find out the value of x. So in the drawing we have semicircle APCB. In addition, we know that this is line segment QC. This equals to 6 units in its length. This is line segment CB. This equals to 5 units in its length. In addition, we know that this is RKP. And it's equal to arc CB in its length. So those two arcs are equal to each other in their lengths. And this is angle PQA, this is a right angle. Again, our task is to find out the length of this line segment AQ, and this equals to x. We have to find out the value of x. This is triangle ACB. Triangle ACB subtend on chord AB, that is the diameter of this semicircle, and according to rule 7, any triangle that subtend on the diameter of the circle or semicircle must be equal to 90 degrees in size. Therefore, this triangle ACB equals to 90 degrees in size according to rule 7. And it is given as a question that arc AP equals to arc CB in its length. And again, according to what is given as a question, arc AP equals to arc CB in its length. And therefore, we can implement here rule 56. According to rule 56, if two arcs are equal to each other in their lengths, then their corresponding chords are also equal to each other in their lengths. In the drawing circle, this is arc AB, it is equal to this arc CD in its length. So those two arcs are equal to each other in their lengths. And therefore their corresponding chords must be also equal to each other in their lengths. The corresponding chord of this arc AB is chord AB, and the corresponding chord of this arc CD is chord CD. So the two corresponding chords are also equal to each other in their length. That is to say, chord AB equals to chord CD in its length. Okay? So if two arcs are equal to each other in their length, then their corresponding chords must be also equal to each other in their length. Very simple. So we can implement rule 56 in our drawing. In our drawing, those two arcs are equal to each other in their lengths, and therefore those two corresponding chords also equal to each other in their lengths. That is to say, chord AP equals to chord CB in its length. Repeat again, those two arcs are equal to each other in their lengths, and therefore their two corresponding chords must be also equal to each other in their lengths. That is to say, chord AP equals to chord CB in its length. So repeat again, according to rule 56, arc AP equals to arc CB in its length, and therefore their corresponding chords must be also equal to each other in their length. That is to say, arc AP equals to arc CB in its length. But it is given as a question that arc CB equals to 5. So we can write here that arc CB equals to 5 units in its length, and for this equation if equals to CB equals to 5, we will write that arc AP must be also equal to, chord AP must be also equal to 5 units in its length. This is chord AP, also equals to 5 units in its length, according to rule 56. In the next step, we join points P and C together by a straight line. By joining points P and C, we can get there triangle PCA. This is triangle PCA that subtend on chord PA that equals to 5 units in its length. Likewise, this is the other triangle CAB. Triangle CAB subtend on this chord CB, it also equals to 5 units in its length. And because of the fact that those two triangles subtend on equal chords, equals to 5, they must be also equal to each other in their sizes. That is to say, triangle PCA must be equal to triangle CAB in its size. Of those two triangles must be also equal to each other in their size according to rule 57. So here we have triangle PCA must be equal to triangle CAB in its size because of the fact that both subtend on equal chords. So if we define the size of this triangle as alpha, then the size of this triangle must be also equal to alpha because they are equal to each other in their sizes according to rule 57. So in this right triangle ACB, this angle equals to alpha, this angle equals to 90 degrees, and therefore this first angle must be equal to 90 degrees minus alpha. Y equals 90 degrees minus alpha plus alpha is 90 degrees, and 90 degrees plus 90 degrees is equal to 180 degrees. It is the sum of the angles in a triangle. Likewise, in this again right triangle PQC, this angle equals to alpha, this angle equals to 90 degrees, and therefore this first angle must be equal to 90 degrees minus alpha. According to the sum, let's say that the sum of the angles in a triangle is equal to 180 degrees. In the next step, we prove that the again right triangle PQC is similar to this right lower triangle, triangle ABC. So what those two right triangles are similar to each other. First of all, those two angles are both equal to alpha, and therefore they are equal to each other. In addition, those two angles are both equal to 90 degrees minus alpha, and therefore they are equal to each other. And finally, those two angles are both equal to 90 degrees, and therefore they are equal to each other. So we prove that all the three angles of this green right triangle PQC, all the three angles of this green right triangle PQC are corresponding equal to all the three angles of this right lower triangle, triangle ABC. And therefore those two right triangles are similar to each other according to angle similarity rule. So if again, if you found out that the right green triangle PQC is similar, this is the sum of similar to the right triangle ABC according to angle similarity rule. And from the fact that those two right triangles are similar to each other, we will derive that the following relationship exists between their sides. We will derive that side PQ of this green right triangle PQC or side CB of this right lower triangle ABC is equal to side QC of this green right triangle PQC or side AC of this right lower triangle, triangle ABC. And again, from the fact that those two right triangles are similar to each other, we will derive that the following relationship exists between their sides. We will derive that side PQ of the green triangle or side CB of the right lower triangle ABC equals to side QC of the green triangle or side AC of the right lower triangle ABC. PQ is the missing side, so limiting is this. CB is 5, QC is 6, and AC in total equals to x plus 6. AC is x plus 6. So total we found out that PQ over 5 equals to 6 over x plus 6. Here we multiply the equation by 5. So here we left only PQ. This equals to 6 times 5 is 30. So total this expression equals to 30 over x plus 6. So PQ, the missing side PQ equals to 30 over x plus 6 units in its length. This is the missing side PQ. This equals to 30 over x plus 6 units in its length. AC is a straight line according to what is given as the question. So if you focus on the upper side of the straight line AC at point Q, here the sum of the angles must be equal to 180 degrees according to rule 3. Rule 3 states that the sum of the angles from one side of a straight line is equal to 180 degrees. So which angles we have at the upper side of the straight line AC at point Q? We have this angle that is 90, this is the right angle, plus this missing angle. In total the sum of those two angles must be equal to 180 degrees according to rule 3. Therefore this missing angle must be equal to 90 degrees in its size. And therefore triangle APQ is a right angle. So in the next step we implemented the Pythagoras theorem on this right small triangle, triangle APQ. According to the Pythagoras theorem, in a right triangle the square of the hypotenuse equals to the sum of the squares of the perpendiculars. So in this right triangle APQ, according to the Pythagoras theorem, AP squared, that is the square of the hypotenuse, equals to PQ squared plus QA squared. And again, in the right triangle APQ, according to the Pythagoras theorem, AP squared, that is the square of the hypotenuse, equals to PQ squared plus AQ squared. AP is 5, therefore B squared is 5 squared, that is 25. And it equals to PQ square. PQ is 30 over x plus 6, therefore PQ square is 30 over x plus 6 square, plus QA square. QA is x, therefore QA square is x square. So in total, we found out that 25 equals to 30 over x plus 6 square, plus x square. So 25 equals to, open the brackets of this expression, 30 over x plus 6 square equals to 30 square, that is 900, plus x plus 6 square. So in total this expression equals to 900 over x plus 6 square, and we have plus x square. So we multiplied x square by x plus 6 square, and then we divided by x plus 6 square in order to confront with this number. So it is x plus 6 times x plus 6 square divided by x plus 6 square. So here we multiply the equation by x plus 6 square, and finally found out that 25 times x plus 6 square equals to 900 plus x squared times x plus 6 square. So we have here 25 times x plus 6 squared. X plus 6 squared equals to x squared plus 6 squared, that is 36, plus 2 times x times 6, that is 12x. And is equals to 900. And we have here x squared times x plus 6 squared. Again, x plus 6 squared equals to x squared plus 6 squared, that is 36, plus 2 times x times 6, that is 12x. Here we open the brackets on both sides of this equation. We found out that 25 times x squared is 25x squared. We have 25 plus 36 is 900, and 25 times 12x is 300x. So total inside of the equation we have 25x squared plus 900 plus 400x equals to, we have here 900 plus x squared times x squared plus 36 plus 12x. Open the brackets of this expression and find out that x squared times x squared is x to the power of 4. X squared times 36 is 36x squared. And x squared times 12x equals to 12x cubed. So in total we found out that 25x squared equals to 900 plus 300x. And the other side of the equation we have 900 plus x to the power of 4 plus 36x squared plus 12x cubed. Here we have 900 on both sides of this equation, so and 900 will get cancelled. After we cancel 900, in this side of the equation we left only with 25x squared plus 300x squared, while on the other side of the equation we left with x to the power of 4 plus 12x cubed plus 36x squared. So here we subtracted 25x squared from this equation, and finally found out in this side of the equation we left only with 300x. While on the other side of the equation, we left with x to the power of 4 plus 12x cubed, and we have here 36x squared minus 25x squared equals to 11x squared. So in total, we found out that 300x equals to x to the power of 4 times 12x cubed plus 11x squared. So here we subtracted 300x from this equation, and finally found out that x to the power of 4 plus 12x cubed plus 11x squared minus 300x equals to 0. So here we took x second factor out of this long expression. So inside the brackets we left with only x cubed plus 12x squared plus 11x minus 300 equals to 0. So this equation has two solutions for x. The first solution for x is that x equals to 0. If x equals to 0, then 0 times everything is 0, and we get the those two sides of the equation are equal to each other. That is to say, 0 equals to 0. So x equals to 0 is the first solution for this equation. The second solution to this equation is that this expression inside the brackets is equals to 0. And 0 times x is 0. We get that 0 equals to 0. So the second solution for this equation is that x cubed plus 12x squared plus 11x minus 300 equals to 0. X equals to 0 is not the right solution, it is an incorrect solution. Why? Because x is the length of this line segment AQ, that is line segment that we are looking for in this question. AQ equals to x. X is a length, and x as a length, it must be a positive number. Okay, again, x can never be equal to 0 because x is a length, and as a length, it must be a positive number. So this solution is a correct solution. X can never be equal to 0. The second solution for x is that this expression equals to 0. 0 times anything is 0. So we get that 0 equals to 0. So the second solution for x, that x cubed plus 12x squared plus 11x plus 300 equals to 0. So first of all, we checked if x equals to 3, solve this equation. If x equals to 3, then x cubed is 3 cubed, that is 27, plus 12x squared. X is 3, so x squared is 3 squared, that is 9. 9 times 12 is 108, plus 11x. X is 3, so 11x is 11 times 3, that is 33, minus 300, equals to 0. 27 plus 108 plus 33 is 168, minus 300. 168 minus 300 is definitely not equal to 0. So x equals to 3 is not a solution for this equation. Then check that if x equals to 4 solves this equation. So substitute x by 4. Check if x equals to 4 solve this equation. So we substitute x by 4. X cubed is 4 cubed, it is 4 times 4 times 4, this is 64, plus 12x squared. X is 4, so x squared is 4 squared, this is 16, and 16 times 12 is 192, plus 11x. X is 4, so 11x is 11 times 4, this is 44, minus 300 equals to 0. So 64 plus 44 is 108, 108 plus 192 is 300. 300 minus 300 is 0. So x equals to 4, solve this equation. Therefore, the first solution for x is that x equals to 4. X equals to 4. Okay, that is the first solution for x. So this, if this expression equals to 0, then this equation is true. So this expression is equals to 0, solves the equation. So then we can present this expression in a different way. Actually, x cubed plus 12x squared plus 11x minus 300 equals to x minus 4 times x squared plus 16x plus 75. Repeat again. Those two expressions are identical, they just have two forms. If you open the brackets of this expression, you get that this expression equals to x cubed plus 12x squared plus 11x minus 300. So we can substitute this expression by these expressions because those two expressions are identical. And therefore, this expression equals to 0. Okay. Now it is very easy to solve this equation. Here we have two solutions that are possible for x. If x minus 4 equals to 0, then 0 times anything is 0. So we get that 0 equals to 0. So the first solution for x is that x minus 4 equals to 0. The other solution for x is that this expression equals to 0. And then 0 times x minus 4 is 0, so 0 equals to 0. This is the second solution for x, for this equation. So the second solution for this equation is x squared plus 16x plus 75 equals to 0. If x minus 4 equals to 0, then x equals to 4. So the first solution for x is that x equals to 4. What about the other solution for x? According to the second solution for x, this quadratic equation x squared plus 16x plus 75 equals to 0. Actually, the determinant of this quadratic equation is b squared minus 4 times a squared. B is 16, so b squared is 16 squared, that is 256, minus 4 times a times c. So it is minus 4 times a is minus 4 times 1 is minus 4 times c. Minus 4 times 75 is minus 300. 256 minus 300 is a negative number. That is to say that the determinant of this quadratic equation is a negative number, and whenever the determinant of any quadratic equation is a negative, it has no solutions at all. And because of the fact that this quadratic equation has no solution at all, then this solution is an incorrect solution. A second way to prove that this solution is not a correct solution, we just substitute 25 plus 64 plus 11. So this expression equals to x squared plus 16x plus 64 plus 11 equals to 0. But this expression x squared plus 16x plus 64 equals to x minus 8 squared. If you open the brackets of this expression, you get that this expression equals to x squared plus 16x plus 64. And we have to add 11 equals to 0. So x minus 8 plus 11 equals to 0. So if we subtract 11 from this equation, if I found out that x minus 8 squared equals to minus 11. X minus 8 squared is the positive number. Again, x minus 8 squared is a positive number, but minus 11 is a negative number, and positive number can never equal to a negative number. Therefore, this is a second reason that this is not a correct solution for this equation. So the only solution for this equation is that x is equals to 4. So if you found out that let me say line segment A cubed is equal to x is equal to 4 units in its length. Repeat again, we have found out that this line segment A cubed is equal to x is equal to 4 units in its length. So we finish with the first question. In the next step, I repeat on the solution of the second question. Our task in the second question is to find out the area of this quarter circle AOB. So in the drawing, we have quarter circle AOB. This is line segment P cubed is equal to 4 units in its length. This is line segment E cubed is equal to 4 units in its length. This is angle PQ8, that is the right angle. Again, our task is to find out the area of this quarter circle AOB. OA equals to OB, the above the area of the quarter circle. So we define the radius of this quarter circle as R. So OA is the radius of the quarter circle is equal to R, and OB is also the radius of the quarter circle is equal to R according to our definition. So in the next step, we focus on this right triangle AOB. In this right triangle AOB, we have the rule that says that in front of equal sides in the triangle there are equal angles. So in front of those two equal sides, we have those two angles that must be also equal to each other, and the sides according to the rule that I mentioned. So if the size of this angle is x, then the size of this angle must be also equal to x because they are equal to each other. And we also know that the sum of the angles in a triangle is equal to 180 degrees. So the sum of the angles in triangle AOB must be equal to 180 degrees. X plus 90 degrees must be equal to 180 degrees. So 2x plus 90 degrees must be equal to 180 degrees. In the right triangle AOB, the sum of the angles must be equal to 180 degrees. That is to say 2x plus 90 degrees must be equal to 180 degrees. Here we subtract the 90 degrees from this equation, and find out that 2x equals to 180 degrees minus 20 degrees is 90 degrees. Here we divide this equation by 2 and find out that the missing angle x is equal to 90 degrees over 2, that is 45 degrees. So this is the missing angle x is equal to 45 degrees inside, and this also the missing angle x is equal to 45 degrees in its size. In the next step, we did the construction, that is to say from point O we do perpendicular on BA. Again, from point O we do perpendicular on BA. So this angle equals to 90 degrees, and this angle also equals to 90 degrees according to our construction. We define the touching point of the perpendicular from point O and BA. This point is point M. By doing this construction, we created here the right triangle AMO. In this right triangle AMO, the sum of the angles must be equal to 180 degrees. So here we have the right triangle AMO. We have this angle that is the right angle, so 90 degrees plus 45 degrees plus the missing angle must be equal to 180 degrees. 90 degrees plus 45 degrees is 135 degrees. So 135 degrees plus the missing angle, this missing angle in total must be equal to 180 degrees. Therefore, this missing angle must be equal to 45 degrees in size. So in the right triangle AMO, we know that in front, in a triangle, in front of equal angles, we have equal sides. So in the right triangle AMO, in front of those two equal angles, we have those two sides that must be also equal to each other in their lengths. That is to say, in the right triangle AMO, sine AMO equals to sine MO. Again, sine AM equals to sine MO. And again, in the right triangle AMO, in front of equal angles, we have equal sides. That is to say, sine AM must be equal to sine MO in its length. But if we define the length of line segment QM as x, then AM in total must be equal to 4 plus x. So we can write here that AM equals to 4 plus x, or x plus 4. And for this equation, x plus 4 equals to AM equals to OM, we regard that the missing side OM must be also equal to x plus 4 in its length. So this is the missing side OM. This is also equal to x plus 4 units in itself. The next step, implement the Pythagoras theorem on this right triangle AMO in order to find out the ref of the hypotenuse AO. AO is also the radius of this quarter circle that is equal to R. So by finding the hypotenuse AO of this right triangle AMO, we will find out the radius of this quarter circle AOB. So in this right triangle AMO, according to the Pythagoras theorem, AO squared, this is the square of the hypotenuse, equals to AM squared plus MO squared. This again the right triangle AMO, according to the Pythagoras theorem, AO squared, this is the square of the hypotenuse, equals to AM squared plus MO squared. AO is the missing side, so limit is it is, and it equals to AM squared. AM is x plus 4, therefore AM squared is x plus 4 squared. OM is also x plus 4, so AM squared is x plus 4 squared. So AO squared equals to x plus 4 squared plus x plus 4 squared, this is 2 times x plus 4 squared. Here we took out all the equation and found out the missing hypotenuse, this is actually the radius of the quarter circle, equals to the square root of 2, and the square root of x plus 4 squared is x plus 4. So in total, we found out the radius AO of the quarter circle equals to the square root of 2 times x plus 4 units in itself. This is the radius AO of the quarter circle, equals to R, and it is equals to the square root of 2 times x plus 4 units in itself. In the next step, we did another construction, that is to say, we do perpendicular on this short line segment PQ at point P. Again, we do perpendicular on this short line segment PQ at point P. So, this angle equals to 90 degrees according to our construction. This is the perpendicular PN from point P of line segment PQ. In the next step, we extended line segment OM by sideline until it touches the perpendicular from point P. We define the touching point of the extended line segment OM with this perpendicular from point P. This point is point N. So here we know that AB, we know that OM is a perpendicular, it is absolutely a straight line. When you extend the straight line by straight line, the result OM must be also a straight line. So ON is a straight line. If you focus on the lower side of the straight line OM at point M, here the sum of the angles must be equal to 180 degrees according to all three. So which angles we have at the lower side of the straight line ON at point M? We have this angle that is the right angle plus this missing angle, and total the sum of those two angles must be equal to 180 degrees according to all three. Therefore this missing angle must be equal to 90 degrees in its size. Likewise, AB is a straight line according to what is given as a question. So if you focus on the upper side of the straight line AB at point Q, the sum of the angles must be equal to 180 degrees according to all three. So which angles we have at the upper side of the straight line AB at point Q, we have this angle is equal to 90 degrees in size, plus this missing angle, and total the sum of those two angles must be equal to 180 degrees according to all three. Therefore, this missing angle must be equal to 90 degrees in its size. So in quadrilateral NMQP, we have 1, 2, 3 right angles. Again, in this quadrilateral NMPQ, we have 1, 2, 3 right angles. This angle equals to 90 degrees according to our construction. Those two angles are both equal to 90 degrees in their sizes according to all three. So in total, in the quadrilateral NMQP, we have 3 right angles. So the sum of right angles is 270 degrees. So 270 degrees plus the size of this fourth missing angle, total must be equal to 360 degrees according to the rule that says that the sum of the angles in any quadrilateral is equal to 360 degrees. So repeat again. In the quadrilateral NMQP, the sum of the angles must be equal to 360 degrees. So 270 degrees plus the size of this the size of the fourth missing angle P and M, total must be equal to 360 degrees. We subtract 270 degrees from this equation and find out that the missing fourth angle P and M equals to 360 degrees plus 270 degrees is 90 degrees. So this fourth missing angle must be equal to 90 degrees in size. So in quadrilateral NMQP, we have 4 right angles, and therefore we can relate quadrilateral NMQP as a right angle. But we also know that the opposite sides of a rectangle are equal to each other. So a rectangle NMQP, side PQ must be equal to the opposite side NM, but PQ is 3, therefore the opposite side NM must be also equal to 4 units in the same. Likewise, according to the symbol, in the same triangle NMQP, side QM must be equal to the opposite side NP. But QM is x, therefore the opposite side PN must be also equal to x units in its length. In the next step, we join points O and P together by straight line. So point O is the center of this quarter circle, point P is the point of the quarter circle itself, therefore OP is the radius of this quarter circle, is equals to square root of 2 times x plus 4 units in its length. So OP equals to the square root of 2 times x plus 4 units in its length. So in the next step, we implement the quadrilateral theorem on this right triangle OPN. This right triangle OPN, PO squared, that is the square of the hypotenuse, equals to PN squared plus NO squared. Okay, then this right triangle PN, according to the quadrilateral theorem, PO squared, that is the square of the hypotenuse, equals to PN squared plus ON squared. OP is the radius of the quarter circle, that equals to the square root of 2 times x plus 4, therefore OP squared equals to the square root of 2 times x plus 4 squared, and it equals to PN squared. Pn is x, therefore Pn squared is x squared, plus NO squared. NO in total equals to 3 plus x plus 4, that is x plus 7. So NO equals to x plus 7, therefore NO squared equals to x plus 7 squared. So in total, we should know that the square root of 2 times x plus 4 squared equals to x squared plus x plus 7 squared. Open the bracket on this side, on both sides of this equation. So square root of 2 squared is 2, and we have times x plus 4 squared. Here we have x squared, and x plus 7 squared equals to x squared plus 7 squared, that is 49, plus 2 times x times 7, that is 14x. So here we have 2 times x plus 4. So we open the brackets of this expression and found out that x plus 4 squared equals to x squared plus 4 squared, that is 16, plus 2 times x times 4, that is 8x. On the other side of the equation, we have x squared plus x squared, that is 2x squared, plus 49 plus 14x. We open the brackets of this expression. We have 2 times x squared is 2x squared, plus 2 times 16 is 32, plus 2 times x is 16x. And it equals to 2x squared plus 49 plus 14x. Here we have 2x squared on both sides of this equation, so 2x squared will get cancelled, and we cancel 2x squared. In this side of the equation we have to only with 32 plus 16x, but on the other side of this equation we have to only with 49 plus 14x. So in total we should find out that 32 plus 16x equals to 49 plus 14x. Here we subtract this 14x from this equation, and we found out that 32 plus 16x plus 14x is 2x, and it equals to 49. Here we subtracted 32 from this equation, and we found out that 2x equals to 49 minus 32 is 17. Here we divided this equation by 2, and we found out that x equals to 17 halves. Okay, this is a line segment Pn equals to x, and x equals to 17 halves. Likewise, this is a line segment Qn, this is equals to x, and x equals to 17 halves units in its length. Okay, again, we should find out that x equals to 17 halves. Our text is to find out the area of this quarter circle AOB. The area of quarter circle is 1/4 of a circle. The area of any circle equals to pi times the radius of the circle squared, and therefore the area of the quarter circle must be equal to pi times the radius of the circle squared over 4. So the area of the quarter circle AOB must be equal to pi times the radius of the circle squared over 4. We only found out that the radius of the quarter circle equals to square root of 2 times x plus 4, and therefore the radius squared equals to the square root of 2 times x plus 4 squared. So in total, the area of this quarter circle AOB equals to pi over 4 times square root of 2 times x plus 4 squared. We open the brackets of this expression, and we found out that this expression in total equals to pi over 4, and square root of 2 times 2 is 2 times x plus 4 squared. 2 over 4 is 1/2. So in total, this expression equals to pi over 2 times x plus 4 squared. This is pi over 2 times x plus 4 squared, but x is 17 over 2, so we substitute x by 17 over 2. So in total, this expression equals to pi over 2 times x is 17 over 2 plus 4. So here we multiplied 4 by 2, then we divided by 2 in order to become quarter with this number. So we have 17 plus 4 times 2 is 8, and we divided by 2, so we change nothing. So total the area of quarter second will be equals to pi over 2. So inside the brackets we have 17 over 8 over 2 squared. 17 over 8 is 25 over 2 squared. So the area of the quarter second will be in total equals to pi over 2 times 25 over 2 squared. 25 over 2 squared equals to 25 squared, that is 625, over 2 squared, that is 4. So in total, the numerator of this expression we have 625 over 4 times 2, that is 8. So in total, we should find out the area that we are looking for this question. That is the area of this quarter second AOB equals to either 625 pi over 8 square inches in size, or in terms of numbers, the area of this quarter second equals to 245.437 square inches in size. Okay, thank you very much.